Hello, fellow chemists. Jolly here again. This discussion is going to be on polyatomic ions and how we would bond them together to make a neutral species. Now, where do we get the polyatomics from? We don't get them straight off of the periodic table because polyatomic ions are clusters of nonmetals that carry a charge. So you can predict them if you do a whole bunch of Lewis structures, which we'll talk about in the future, but you can't get them off the periodic table. So where do you find them? We have to have a table, or the ultimate goal is you are supposed to know them and recognize them. And just as a hint, you should know them from their formula. You should know their charge and their name. Now, on the Jolly reference sheet, or the Jolly cheat sheet as I lovingly call it, it is the last green page and it's all the way at the top and it's written very tiny. Now I'm going to put a few of them here just to give you an idea in case you're not staring at that chart, but any textbook, or you can look them up online. All right, so on that polyatomic chart, I start with the cations, so I have a +2, and then I have, no I don't, I have a +1, and then I have a +2, and then I go over into the anions, and I have a -1, a -2, and a -3. So these right here, it's a pretty short list. These are my cations. And this is a much larger list. These are my anions. And I'm not going to list them all, but just some common ones. All right, the most common polyatomic with a +1 charge is called ammonium. It's not all that common, but I use a polyatomic called the mercury 1, which has a +2 charge. Now notice this isn't matching my definition of nonmetals. It's the only one that kind of deviates. In my -1 column, one of my favorites is hydroxide, and you can put the negative here or there. It doesn't matter. And then some families. Oh, and I love the nitrate family because its partner, is nitrite, which is a 2. But they both have a -1 charge. Another one is acetate. And it has a -1 charge. Now, yes, there are others, but I'm going to just stop there because you can look them up. The -2 family, oh, I do love the sulfate family, or the sulfur family. So I have sulfate and sulfite. And who else do I have? Ooh, carbonate. And then my -3 family, the most popular one, is the phosphorus family, which is phosphate and oops, that's a 3. Phosphite. All right, so that's a generic list of some of the polyatomics. And again, I really, yes, I'm serious about that. I really suggest you know those for your polys. It'll make your life so much simpler. Make note cards, do something, but try and figure those out. If you have access to my stuff, you can take a little polyatomic quiz, and I just have these little silly quizzes, and it comes up and says, what's its name, what's its charge, what's its this, just as a little quiz to help you remember those. Okay, so we've got our polyatomic ions. How are we going to balance them? Well, the same way we did the monoatomics. And what do we know? Nature loves neutral. We are going to do the exact same thing. So I'm going to draw a cation on this side. And ooh, my list is so long. Which one am I going to choose? I'm just going to choose the ammonium. And then I'm going to choose some anions. Let's put a -1, so we'll use nitrate. We'll use let's use sulfite, and let's use phosphate. How would we put those together? All right, when you're dealing with polyatomics, I suggest you always start with parentheses, whether you use them or not. So I'm going to put my ammonium right here. I'm going to put parentheses around it, and I'm going to start with the top. So I'm going to put the nitrate with it and put parentheses. And if you'll notice, this one goes here just the same. That one goes there. That's a positive, by the way. That one goes there, and so it would be rewritten as NH4NO3 because it's a 1 and a 1. Now, when do you need the parentheses? You only need the parentheses if you have a subscript. So the only time you need parentheses is if there is a subscript. But there's absolutely nothing wrong with drawing them at first. But I could have rewritten this as NH4NO3. And you're supposed to just recognize those as polyatomics. All right, well, let's put another combination together here. How about the ammonium with the sulfite? Remember, that one goes there, and the 1 goes there. So for an overall, NH4 subscript 2 parentheses SO3. Remember, I'm not putting the charges anymore, the numbers. Ooh, that looks good. Let's just do a double check. I have 2 plus 1 charges plus 1 minus 2 charge is neutral. Yay! Now the parentheses. I could also write it like this. Perfectly acceptable. Perfectly acceptable. And let's do our last variation. Let's put that ammonium with the phosphate. I'm going to jump straight to the answer. Can you see why I did it? Let's check our charges. I have 3 plus 1s, and I have 1 minus 3, so overall neutral. And that is how you would put together polyatomic ions. Now, what is it about these ions that are so interesting? Well, nature loves neutral, and there's a lot of charges out there, and so these are also called the salts. Not just sodium chloride, but the salts. So ionic compounds are generically also called salts. All right, I suggest you go and practice some of those combinations between polyatomics and, mix and match. Put some polys with some monos, just balance them. And if you have my practice problems, there are a whole bunch. And you can also go to my nomenclature section, and there's a whole bunch there. Practice makes perfect. Jolly out.